All right, let's look at this bean counting problem. And I totally recognize that the context is still contrived, but this is so much more fun. It's just so much more fun than looking at a boring picture of a house and trying to figure it out. Okay, so if we look at our two people, we've got Dan, and we can think about the job, which was one, filling 1 cup with beans. We have his time, and then we can figure out a rate. So I'm setting up these little tables is really what I'm doing, something like this. Okay, and it really goes, it's leading you up to this idea of distance equals rate times time. We can solve a ton of problems if we understand this relationship. So Dan filled 1 cup of beans in 22.6 minutes. So his rate, so I'm going to think about this as 100% or 1 divided by 22.6 minutes, which means he does 4.4% per minute. Okay. Now Chris did the same thing. He filled the glass with beans, but it took him much less time. He had 5.6 minutes. And if you'll notice, they were both looking or listening to headphones. That was to keep their rate steady so that they could actually make this problem work out. So he filled the whole thing, which is again 100%, and we are going to divide that by 5.6 minutes. So that gives us 17.9% per minute. Okay, now our job is to figure out how much time it takes for them to work together, if they are working together. So Dan plus Chris is 4.4% per minute plus 17.9% per minute, which is 22.3. Okay, and that's percent per minute. Now, we want to know how long it takes them to fill it. So we want to take the reciprocal of that, or we want to multiply or divide 100% divided by that. So if I take 100% divided by 22.3% per minute, the percents are going to be left out. By taking the reciprocal, minutes becomes into the numerator, and I get 4.5 minutes. Okay, hopefully you watched the video to find that solution. Now, push pause on this video and go ahead and continue through the activity, and then I will show the answer to the second question in the rest of this video. Okay, so you can come back and watch it, but I want you to push pause now. All right, did you do problem 2? Because if you skip ahead, this isn't going to make sense. Okay, so for the next part, you'll notice that they had 3 people. So we know that we have Dan and Chris. So we know that they're still filling 1 jar with beans. We know that their time was 4.5 minutes. So we take their rate, and that's 100% divided by 4.5. Okay, I'll figure out what that is in a minute. So now we have Dan plus C. Oops, I'm going to erase that. Now we're going to add Annie to it. And we know that Dan plus Chris plus Annie. So all 3 of them working together still fills 1 container, or Annie's filling 1 container by herself. I don't know how long it took Annie to do it by herself, but I know that all 3 of them working together only took 3.4 minutes. So that's 100% divided by 3.4. All right, so I'm going to grab my calculator, figure out what these are. Okay, so I have those rates, and now I can't average these two because I'm really asking that 22.2% their rate plus some other rate equals 29.4% per minute. Okay, so if I subtract those, 29.4 minus 22.2 is 7.2. That is 7.2% per minute. Okay, so that's my x in this case. So if I take that and I want to find the reciprocal of that so that I am figuring out her time. So I want minute per percent. So if I take 100% divided by 7.2, I get 13.89. Okay, so watch the rest of the video and see if we get something pretty close to 14 minutes. Okay, we've got some rounding error here because I'm truncating my decimals a little bit. So see if we are pretty close to 14 minutes. Okay, all right, good luck with this. I hope that you enjoy working with rates.